Welcome to Khetz tutorials, and in this video I'll be doing question 3 from 1.2 exercises in James Stewart calculus. So we're asked to match each of the equations to its graph. So let's analyze each individually. So now let's start with A. At A we have y equals x squared. So this is a quadratic equation, a quadratic function, and this is usually the base that we use to interpret some other quadratic functions. So we know that this has an a of 1, which means it's positive, so expect it to face upwards. That's the first thing. And it has a turning point at 0. So the q here, remember that your normal form of this equation is like this. So our q in this case is 0. And if you look at this, our p is also 0, because if you substitute, our a is 1, you substitute a p of 0 and a q of 0, then you just have x squared. This is x minus 0, so that would be x squared, and that's exactly what we have. So in other words, the turning point of this is at 0, 0. So the TP turning point is at 0, 0, and that is where that is. So let's see if we have such a function on the diagram. Expect it to look up, we expect it to look like a quadratic function, and we expect it to have a turning point at 0, 0. So there are other factors that you can consider, but this should be enough for us to decide. So let's see if you have such a case. So this is what we have. And another thing it would be its ascension, so how much it grows by, as well as how narrow it is towards its turning point. So expect this to be quite narrow towards the turning point, and then just increase outwards. And you can use a bunch of values to evaluate that. So you substitute a 0, then you have 0, substitute a 1, you have 1, substitute a 2, you have 4, and so on, just to see how fast it would grow and how small it is towards 0. So this one matches exactly what we just discussed. So the first one, 3a, would be h. Moving on to x to the power 5. So that one has an odd power. So whenever you have a polynomial that has an odd power, it can be closely associated with y equals x cubed, which looks like this, or in its other form like that. In this case, our a, or the coefficient of that power, is positive, so we expect it to look like this. So expect it to point upwards at the end. So that is the first thing which we're going to notice there. And if we look at what we have, this is the function that resembles that behavior. This one here. So that is f. And finally, we just have 1, and we could just default it to the last one, which is g. And you can also figure this out or work on this. It has a positive power, so it resembles x squared, which would look like this, but then it is wide as you approach your 0 point, and you can plug in a bunch of values to confirm that.